Modern search almost never relies on one ranker anymore. You run dense vector search for meaning and sparse keyword search for exact terms. And now you have two ranked lists that disagree. How do you merge them into one without a fragile pile of tuning? Cormack and colleagues answered that back in 2009 with something almost embarrassingly simple. It's called reciprocal rank fusion, and it quietly became the default. Let's break it down. Follow a single query through the fusion, and you'll see why this works. Watch how the two lists become one. The first input is dense vector search, which returns a ranked list. Every document gets a position, first, second, third, based on how close its embedding sits to the query. This side captures meaning and paraphrase. Alongside it, sparse keyword search, usually something like BM25, returns its own ranked list. Same documents, often a completely different order, because this side rewards exact term matches rather than semantic similarity. Here is the trick at the center. For each document, take 1 divided by the quantity k plus its rank in a list, where k is a small constant around 60. Do that in every list where the document appears, then add those pieces together. Adding up all those contributions gives each document a single fused score, and sorting by it produces one merged ranking. Documents that rank well in both lists float to the top, and you never touch the raw scores at all. Compare that to the obvious alternative, and the appeal becomes clear. There's a reason people stopped blending raw scores. Blending raw scores directly sounds natural until you try it. A cosine similarity and a BM25 score live on totally different scales, so you have to normalize them. And that normalization is fragile, dataset specific, and endlessly fiddly to tune. Reciprocal rank fusion sidesteps all of it by using only ranks. Position 1 is position 1 whatever the underlying metric was, so there's nothing to normalize, nothing to train, and nothing to retune when your data shifts. Robust by construction. So why did this stick around? 3 properties explain it. Keep these in mind and you've got it. The whole method is one small formula. Score a document as 1 over the quantity k plus rank summed across lists. That is genuinely the entire algorithm. No hidden machinery underneath. It leans on ranks, not raw scores. By ignoring the actual numbers each ranker emits, it dodges the incompatible scale problem entirely and stays stable no matter which retrievers you plug in. And it needs no training and almost no tuning. That robustness is exactly why reciprocal rank fusion became the default fusion step in hybrid retrieval and modern RAG stacks everywhere. Let's pull the essentials together. For takeaways to remember, reciprocal rank fusion from Cormack and colleagues in 2009 merges several ranked lists into one clean, unified ranking. For each document, sum 1 over the quantity k plus its rank across every list, with k a small constant near 60, then sort by that score. Because it uses ranks and not raw scores, there's nothing to normalize, nothing to train, and nothing to retune when the data changes. That robustness made it the default way to fuse vector and keyword search in hybrid RAG. If explainers like this one land for you, you'll find a growing shelf of them waiting at Standarity.com. See you in the next lesson.